Let's talk about the evaluation node. The evaluation node is located in the graphs palette. This node evaluates and compares predictive models by showing how well models predict particular outcomes. There are different types of graphs that can be created by the evaluation node. Here we're looking at an example of a gains chart. Notice that we're also only looking at one of the categories of the target field. In this case, we're looking at churned. Now, the evaluation node, when we're creating a gains chart, what it does is it compares a baseline model and a perfect prediction model to the current model. In this example, the baseline model is just predicting at chance, and that's represented by the thick red line. The perfect prediction model is another theoretical model that is never making an error when you make a prediction. That's represented by the thin blue line. Our model is the one that's in between, so it's better than an at-chance model and not quite as good as a perfect prediction model. Now, the way we can interpret this graph, the vertical axis of the gains chart is the cumulative percent of hits, while the horizontal axis represents the ordered percentile groups, and they're ordered based on model prediction and confidence. Now, the way we really interpret this is, for example, if we look at the baseline model, which again is represented by the thick red line, you can see that as we've gone through 20% of the data, we have correctly found 20% of those customers that have churned. As we've gone through 40% of the data, we have correctly identified 40% of the customers that have churned. And again, we're just predicting at chance. Whereas if we look at the perfect prediction model, as we've gone through the first 20% of the data, we've already correctly identified more than 40% of those customers that have churned. As we've gone through about 42% of the data, we have correctly identified 100% of the customers that have churned. And at that point, the model just flattens out. Our model starts off pretty strong. For example, when we've gone through the first 20% of the data, we have correctly identified about 41% of the customers that have churned. When we've gone through about 40% of the data, we've correctly identified about 78% of the customers that have churned, and so on. Let's go through an example of how to use the evaluation node. So we're going to go down to the graphs palette, and we're going to connect our generated model to an evaluation node. Notice that the evaluation node, its name changes automatically when you connect it to a generated model. That's because the evaluation node is going to allow you to evaluate and compare predictive models and then choose the best model for the work that you're doing. Now here we only happen to have one model, but if we had several models, we can use the evaluation node and we can compare the different models as we evaluate them. Now, before we use the evaluation node, notice that I also happen to have a distribution node here on the canvas. I'm going to run the distribution node, and I'm just going to point out one little thing, and we're just going to remember that when we run the evaluation node. So I'm going to run the distribution node, and this is the distribution of our target, of our outcome variable. Notice that churned has a value of about 44%. About 44% of customers have churned. Okay, we'll close out of that window, and we're just going to remember that number in a minute. So let's edit the evaluation node. Now the evaluation node is going to allow you to create different types of graphs. It allows you to create a gains chart, a response chart, a lift chart, a profit chart, and an ROI chart. You can create any one of these. We'll end up creating a couple of them so you can get a general idea as to what's going on. Just to define a gains chart, which is the first type of graph that we're going to create, a gains chart is going to be defined as a proportion of total hits that occur in each quantile. So basically, it's going to be the number of hits in a quantile divided by the total number of hits. So that's what a gains chart is going to do. And before we actually create it, I just want to point out a couple of things. We are going to show the cumulative plot of gains so that we can see what the gains are in one quantile, and then we'll see what the gains are in the next quantile as we're going for a cumulative effect. We're also going to include a baseline model. This is going to be a theoretical model. It's an at chance model where you're basically just making your predictions at chance. And we're also going to include the best line model. That's including, again, another theoretical model. It's a perfect prediction model where we make no errors in our prediction. Now let's run the model. I'm going to expand the size of this window. And I want to point out a couple of things here. First of all, what I want to point out is that notice that we are only showing the results for the churned group. That's because you only show the results for one category at a time when you happen to have a categorical outcome variable, like we do in this case. So we're only showing the results for the first group, whatever the first default group happens to be. In this case, it happens to be churned. Now, let's point out some characteristics of the gains chart. On the left-hand side, on the y-axis, we have the percent gained. So what we have here is at the value of 0, this is where we have found 0% of those people that have churned. When we get to a value of 60, for example, this is where we have found 60% of people that have churned. And when we get to a value of 100, this is where we have found 100% of the people that have churned. So this is telling us the percent gained. Obviously, we want to get up to 100% so that we've correctly identified all of the people that have churned. Now let's take a look at the values on the x-axis. On the x-axis, we have our data that's arranged in order of confidence. So for those people that we are the most confident in our predictions, the most confident that they have churned, they're going to have their values over by the 0. For those people that were the least confident in our prediction, they're going to have their values over by the 100. Okay? Now notice that we happen to have 3 models in this graph. The thick red line is representing the baseline model. Okay, it's a theoretical model. It's a model that's just predicting at chance. The blue line is showing you the perfect prediction model. That's the model that makes no errors. And then the model that you have in between, that's our model. Now let's talk about what this is showing you. Notice the baseline model, the thick red line. Notice that as we go through the top 20% of the data, we've correctly identified 20% of the people that have churned. As we've gone through the top 40% of the data, we've correctly identified 40% of the people that have churned, and so on. So eventually, once we go through 100% of the data, we've identified 100% of the people that have churned, but of course we've gone through the entire data. Now let's take a look at the perfect prediction model, which is the blue model. Notice that it starts off very steeply. That's what you're going to see. It's not making any errors in its prediction. Notice that once it gets to a little past 40%, in fact it ends up being 44%, it flattens out. Now why does it flatten out at 44%? Well, remember we ran a distribution node and we saw that about 44% of the sample had churned. So once it's gone through the first 44% of the sample, it's identified all 100% of the people that have churned, and at that point it no longer can improve, so it just flattens out. Now this is our model. Our model, notice that it starts off very steeply as well. Okay? Notice that as we've gone through about the first 20% of the data, we've correctly identified about 43% of those people that have churned. When we've gone through about 40% of the data, we've correctly identified about 77% of the people that have churned, and so on. So this is showing us information in terms of how well our model did. Clearly we had some rules in the model where we were doing great in terms of our predictive ability and predicting those people that have churned, and then at some point our model is not doing quite as well. Okay? Now This area right here, this is known as the area under the curve, and that's how much better our model is than the at-chance model. You also have this area up here, and that's where our model could still be improved. Okay, we certainly are not at the perfect prediction level. So that's the basic idea in terms of what the type of information that you're gaining from a gains chart. Now let's close out of this window and let's edit the evaluation node again. Let's create a different type of graph. This time what we're going to do is we're going to create a lift chart. So we're going to select lift. Everything else is still going to apply. We'll click on the run button. And we'll just expand the size of the chart. The lift chart is another way to represent the same type of information. Okay? The lift chart is showing you the improvement in expected return over no models. So what the lift is showing you is it's showing you the percent of records in each quantile that are hits divided by or compared to the overall percent of hits. So what do we have here? Again, we happen to have 3 models. Notice again that we're only talking about the category churned. And on the x-axis, we have the data set up exactly the same way that we had it with the gains chart. We have our data arranged in terms of confidence, and those records for which we're most confident in our prediction, they're going to be at the value of about closer to 0. For those records that we have the least amount of confidence in our prediction, they're going to have a value, they're going to be closer to the value of 100. The lift is showing you how much better a model is than a baseline model. The baseline model is the model that just flattens out at a value of 1. So for example, if we happen to have a model that is at a value of 2, that means that it's 2 times better than a baseline model. Okay? If we happen to have a model that is at a value of, let's say 2.25, it's 2.25 times better than a baseline model, and so on. So what we can see here is we have the perfect prediction model, and again, it's making perfect predictions until we get to we've gone through about 44% of the data. Okay? Notice that the lift that we have there is a lift of 2.3. So it's telling you that when we've gone through about 43% of our data, our perfect prediction model is about 2.3 times better than a baseline model. If we take a look at our data, when we've gone through about, let's say, the first 10% of the data, our model is about 2.25 times better than a baseline model. When we've gone through about 20% of the data, our model is about 2.1 times better than a baseline model, and so forth. Now, when might you use something like a lift chart? Well, let's say that you're going to have some kind of advertising campaign, and you're going to send out some kind of mailing, and you can't afford to send out mailings to all of your customers. Instead, you want to target the customers that are most likely to respond to the mailing. So let's say, for example, you know you have a budget where you can afford to send information off to 30% of your customers. Well, if you look at the lift chart, and if you target the correct 30% of customers, you're going to be able to have a lift of about 2. So it's going to be better than 2 times better than a baseline model, as opposed to just sending information, these pamphlets, off to just customers at chance. So that's when you might use a lift chart, for example. Now let's close out of this window and let's talk about a couple of other options. We're going to edit the evaluation node. Now, every time that we've run the evaluation node, we've always just looked at the first category. You're not always going to want to look at the first category, so we're going to talk about how to change which category you define as a hit. So let's create a gains chart again. We'll select gains, and we're going to go over to the options tab. And what we're going to do is we're going to specify how to define a hit. So we're going to click on user define hit, and now we're going to specify the condition as to how we're defining our hit or our target. So we're going to click on the expression builder, and we're going to define our expression. And what we're going to do is we're going to move over to the @functions group, and we're going to select the function @target. This is going to specify our target. We're going to put it into the expression builder. We'll click on the equal sign, and then what we're going to do is we're going to go down to our outcome variable, the variable status, and we'll select that variable. We'll click on the field values number, and we're going to select the category of interest. In this case, it's the current customers. So we'll select current. Now we're specifying that our target is going to be the current customers. We'll click OK. We've specified that now. At this point, we can click on Run. We can expand the size of our graph, and here we have our gains chart, but now notice that we're looking at current customers, not the churned customers. So that's how you could specify an additional category that you want to take a look at with this graph. Now let's talk about a couple of more options. We'll close out of this window, and we're going to edit the evaluation node. We're going to go back over to the plot tab. We've talked about the gains chart already. Let's talk about the response chart a little bit. The response chart is going to be simply the percentage of records in the quantile that are hits. So that's another type of graph that you can create. It's going to actually look fairly similar to a lift chart, except that it's looking at percentage of records that are hits as opposed to the lift. Let's talk about a couple of other options as well. Another type of graph that you can create is you can create a profit chart. If we click on profit for a moment, notice that we have additional options that become available. And that's because the profit is going to equal revenue for each record minus the cost for each record. So here, for example, you could specify how much it costs to process every record. It could be a fixed value or a variable value. And then you're going to also specify how much revenue you get when you get a correct hit, and how much that would cost, how much revenue you would get. It could either be fixed or it could be a variable value as well. Now, one other thing to note is that you could specify this cost and revenue for both profit and for ROI. Okay, so the ROI charts are actually going to be pretty similar to the profit charts, except that ROI, or return on investment, is also going to compare profits to cost for the quantile. So that would be the difference there. Okay, so those are the different types of graphs that you can create. Let's talk about some other options that you have here as well. In terms of the models or the fields that you're going to be showing in the evaluation node, the default is that the model output is going to provide the metadata, and so you're going to end up modeling or showing the results of models. You could also decide that instead of doing that, you can just base on the field name format to choose which fields are going to be displayed in the evaluation node. You also have the plot score fields. Here you can select one or more continuous fields, which might be useful to rank records in terms of propensity to be a hit, for example. If we happen to have a partition node, we could have shown the results for both training, testing, and validation data sets if you had chosen that. We didn't happen to have that in this example, but that could have been done. The plot option that you see here, here you could select the size of the quantiles to plot in the graph, and you can choose whichever one of these might be most convenient for you. Percentiles is by far the most common. Other options that you have here, weight. With the weight, if your records in the data represent more than one unit, you can use the frequency weights to adjust the results. So that's what that is referring to there. Let's go over to the Options tab to talk about some additional options there. We've already talked about how to specify a user-defined hit. So there you just specify a condition, you specify what your new target is going to be, and then you can create a graph for those other categories of your outcome field. The user-defined score, that's how you can define how scores are going to be calculated. So we don't necessarily have to define them by what we have as the default, which is whether a value was correct or wrong. You could also include a business rule. That allows you to select, for example, certain customers who might meet certain criteria. Okay, and you can specify whatever that criteria might be. And the final option that you have here is that you could export your results to a file if you'd like, and then you specify the location of the file and what the delimiter is going to be. Let's click on the Appearance tab. Here you can add in things like titles, subtitles, and labels. And if you go over to the Output tab, here you can decide whether you want to send your output to a screen or if you want to send your output to a file. So we'll just close out of this window. And those are the options that are available within the evaluation node.